Good morning. Welcome everyone. Welcome to the Pearcey Foundation Australia 4.0 discussion series. My name's Wayne Fitzsimmons and I happen to have the privilege of leading the Pearcey Foundation in Australia as its current chairman. The Pearcey Foundation acknowledges all the traditional custodians who belong to the lands where the Pearcey Foundation and you, our guests, meet, live and work. We acknowledge the Aboriginal and Torres Strait Islander people with us today and their elders past, present and emerging, whose stories, traditions and living cultures in this country are a valuable resource, as are those of us all who have come to make Australia our home. Together we are Australia. Good morning to all of you, wherever you are in Australia or overseas. Welcome to today's Australian 4 session where we will be discussing the consumer grid. Australia 4 is an initiative of the Pearcey Foundation to recognise that in moving towards a net zero emissions Australia, the transition of our electricity system to a decarbonised environment presents an enormous number of challenges, which with each of those challenges comes very significant opportunities. Today, we are applying a particular digital and data lens when looking at the intersection of the electricity system with the ICT sector during this transition period. This series of discussions is targeted at bringing the energy, power industry sector and the ICT sector together to identify the challenges and opportunities arising from this transition. We look forward to identifying some productive insights to benefit the whole of the community. On October the 30th this year, we will have a half-day summit to bring everyone together in Sydney to consolidate these insights and learnings and to continue to move forward as a nation. Full details on the summit will be put on our website. It's advertised now, but we'll have registration there for it. It'll be an in-person event at the Sofitel. We would like to acknowledge our sponsors, the Australian Computer Society, the University of Melbourne, Monash University and the University of New South Wales. Without their support, these sessions would not happen. We greatly appreciate that support along with all of the speakers as well as the organisations with whom they represent. We have had active collaboration with a raft of organisations, including Engineers Australia, the EESA, the Melbourne Energy Institute, the Monash Energy Institute, the Australian Institute of Energy, to mention a few. Please note that this session is being recorded and will be published in a few days on our YouTube channel. We will have a transcription of these events as well available. The first 5 recordings are currently available on our website. And I'd like to also acknowledge my colleagues, Jennifer George, Colin Farrelly and Jordan Green, who are not here today, but were actively behind the scenes with me. It's now my great pleasure to hand over to today's moderator, Tim Ryan. Over the last 5 years, Tim's worked closely with the regulatory bodies, AEMC, AEMO, the AER and the ESB on rule changes and implementations for integration of the consumer energy resources, the CER. In particular, the importance of data to deliver consumer outcomes has been his focus. Tim has developed specialist expertise in real-time energy disaggregated metering and monitoring and transactions, which are heavily dependent on accurate data. Currently a member of the ESB Customer Insights Stakeholder Steering Group. Tim has been an ardent, committed supporter for Australia 4.0 from the outset. And I regard Tim as eminently qualified to lead today's discussion on the consumer grid. Tim.
Thanks, everyone. First of all, I'd like to thank Telstra and Jenny for hosting us today. It's been very kind of Telstra to make this facility available to us. Very challenging, though, a little bit to get people out and about in Sydney at the moment. So we don't have quite as many people here live as we would have liked, but heaps of people online. Today we're going to talk about the consumer grid and how the grid has changed and where we're expecting to end up as the consumers actually rest control of the grid from potentially the retailers, generators and otherwise, as they become direct participants in the market. We've got some really great speakers today. We've got Simon English who's going to lead us off, who's from City Power, Powercore, and United Energy as their technology manager. I'll leave it over to him first, and then we'll follow through with Lachlan Blackhall and then Lynn Gallagher.
Thanks, Tim. I assume everybody can hear me. Can I have the first slide of my slide deck up, thanks? So welcome everyone to the discussion this morning. I've got just 4 quick slides to talk about, I suppose, what we as a network business see the challenges and opportunities associated with, the consumer grid. Apologies, there's a lot of data on this slide. It's an internal presentation, but we use as some reference material. So the actual content, don't worry about reading the specific details. I just wanted to highlight that we see that the concept of the intelligent home as being a key enabler for the consumer grid, that these new technology standards like Matter, which are coming out in terms of how a smart home will operate, and a subset of that being energy management will occur. And the fact that it's being adopted by all the major technology players in terms of Apple, Google, Amazon, Samsung, means that we expect the true home integration piece for behind the meter resources will occur quite natively. And that from a utilities perspective, long term, we're going to have to integrate and interact with potentially new players in the market, because there'll be Apple and Google and Amazon, who traditionally we've not dealt with. We've tended to focus on the devices. So we see that as being a significant change in the ecosystem going forward. Can we go to the next slide, please? There's a lot of talk and investment from a federal government perspective around community batteries. We certainly see that over time, they'll become a bit ubiquitous, that there'll be energy storage devices at the community level, so at the street level and at sort of a regional country town level, that offer real good opportunities both for the consumer and also for us as the network. And we see that growing significantly. The really interesting part for us is, as a front of what we call front of meter, so in front of the home type device, traditionally it's only ever been traditional network devices. So it's going to be a different and challenging world for distribution networks, because now we have these active generation and load devices that we don't necessarily own. We could own them, third parties may own them, but they actively contribute to how we manage the network. And so that's new and different for us. Yeah, the next one. And the big disruptor, ultimately the big disruptor is going to be EVs. Ultimately, you can see at the bottom of that slide that most of the car manufacturers that import into Australia have plans to only supply EVs sort of after 2030, 2035. So that means that, even though the uptake of EVs at a state by state level is mostly behind schedule from a government perspective, in terms of our ability to buy something other than EV will be limited in that time frame. The real key thing for us from a network perspective is obviously that's additional load on the network, but what we call vehicle to home, vehicle to grid, or vehicle to X is really the game changer, and it will be the big disruptor, because it means that you can charge your vehicle, which effectively is a mini power station on wheels and a data platform, because you've got solar or whatever energy source locally, could be an industrial facility or a commercial business or your home, and then you can drive it and discharge behind the meter in the new location. So effectively, you've got arguably a competing distribution network. So EVs offer this opportunity to move energy around our system that we've never been able to do before. It just hasn't been practical. So that's a massive disruptor to how effectively the electricity system works. And so I'd encourage you to think about it from a technology perspective that, an EV might be a car, but really it's a data platform and it's a power station on wheels. Okay, next slide, please. So what does that mean from our perspective as a distribution utility? Well, when we look at the electricity network, what would you call the customer network? Today we refer to it as the low voltage network. But effectively, this customer network occurs because we today have a very engineering centric view, right? We think of it as an electricity network, poles and wires, and we treat it sort of internally as this network solution. You're not a customer, you're a connection point. That's going to transform into sort of active engagement with customers. So that's a very different model for us moving forward. Today, we look at the network in the context of the physical limitations. It's capacity. So it's like, how big is that transformer? That's the physical limit of the network. We're moving to a world where with all this, customer energy resources, so PV, EVs, community batteries, it'll be an optimization exercise. So with optimization, we can effectively allow more things, what we call hosting capacity, onto our network for the same poles and wires capability. So that's, again, a very different world. We design our networks today around discrete standards, rules of thumb, engineering principles. We're going to have to move into a much more data-centric view, where the data is going to unlock how we manage and design those networks, versus today where we've tended to roll them out. Distribution networks are rolled out under a fundamental set of standards. And the last point is that we've traditionally, because they've been our assets, we control stuff. So if you think about what happens in a zone substation, in your suburb level, and SCADA platforms and these sorts of technologies, we tend to manage and actively manage a particular type of device because we own it. We're moving to a world where a lot of these devices we won't own. They're customer assets, so we're moving from a control methodology to an orchestration methodology and a fleet management capability. And again, that's a very different world than what we are in today. And with that, I'll hand it back to Tim.
Oh, and that was really insightful. And I think that last slide of yours really gets to the point of why we're here today and what's changing. So we're going to have Professor Lachlan Blackhall next from the ANU. Lachlan's also the head of entrepreneurship there and has been involved in startups and other things in energy as well. Welcome to Lachlan.
Oh, good morning all here in the room and those who are online. Could we bring up my slides, please? Just as we're bringing these up, please allow me to acknowledge the traditional custodians of the land on which we're meeting today, which here is the Gadigal people of the Eora Nation, and obviously pay my respects to elders past and present here and around Australia. Thank you. So my current day job is as head of the battery storage and grid integration program, and I won't delve into this too deeply, but our work sort of spans the gamut of sort of fundamental work on battery materials and battery chemistry, really thinking beyond lithium, which is going to be really important when we start to think about stationary storage. We've got work covering sort of energy systems modelling, optimisation and control, which sort of ties in nicely to what Simon was just talking about. But the work I'm going to sort of just focus on briefly, which I think is really crucial when we're thinking about people, households and communities, is actually the importance of a focus on social science, policy and regulation. And so I'm really pleased, despite being an engineer myself, that we have the largest energy social science team in the country as part of the program. And I think everyone is comfortable with the notion that we need engineers and computer scientists and technical folk to support the transition. Everyone understands the importance and the role of economists, but I think there's a real absence of an understanding about the important role of social science and engagement with people and communities directly. So if I can leave you with sort of one takeaway from the presentation today, it's that social science allows you to measure twice and cut once. And if you're going to spend $100 billion on transitioning your energy system, it probably is really good to maybe measure twice or three times before you go and build all of this new infrastructure. So this will hopefully be a bit of a recap. I know this was covered in a previous session, but ultimately we are in a period of energy transition, and we're moving from particularly an electricity system that had large centralized fossil fuel fired generation with one-way flows of energy from where it was generated to where it was being used, to what you see on the bottom half of this slide, which is an energy system that has very significant amounts of energy generation and storage embedded in what was classically called the demand side. And I like to think of this model that we're transitioning to as being a little bit like a barbell. And what I mean by that is we're going to have about 50% of our generation and storage assets as large-scale wind, solar and storage that sort of will still be utility scale. But at the other end, we're going to have 50% of our assets, generation and storage in the form of residential and community solar PV, residential and community batteries and electric vehicles. And these two big chunks of assets are actually connected by pretty skinny poles and wires. And to Simon's point, I see the most challenging part of the transition at the moment is actually focusing on these skinny poles and wires and the assets that connect into them. And so that largely represents the challenge around the distribution network. Now, when we're talking about consumers, I think it's particularly easy for technical folk, and I know I have been guilty of this myself in the past, of saying like, oh, we've got assets and we've got gadgets and we've got apps, and ultimately people are going to be so excited by this technology. And I would probably say that after a decade of building all of these technologies, actually what people and households want is this. This is the best user interface element to the energy system that we've ever built, all right? And ultimately, our goal is to make the light switch ubiquitous tomorrow as the light switch is ubiquitous today. And what I mean by this is, yes, people want electric vehicles and solar on their roof, and they want batteries, and they're happy to have all of these assets. But in the same way that when we build a consumer electronics device, we don't ask people to understand the difference between TCP/IP and UDP. Customers in the energy sector just simply do not care about how we make it work. They want it to work, they want it to be cost effective, they want it to support the transition, and ultimately they want energy that is available and abundant so that they can use it for living their lives, keeping their family safe and healthy. And I think that's a really important reminder to all of us that this is our ambition, actually. So we want to build ubiquity in the same way that you can pick up a mobile phone and know nothing about how the mobile telephony network works. So how do we do that? I'm just going to touch very briefly on a couple of enabling capabilities, and particularly in the context of thinking about digital and ICT technologies that we're going to need. So for the reasons I talked about before, there's a huge amount of work underway in distribution networks, and the timescales of operation. So I realize this writing is very small. I'm happy to share the documents from which this comes from if anyone wants to email me. My contact details are available at the end of the deck. When we're thinking about the transition that the networks are on, that spans all the way from planning timescales of many years to operational timescales, which in some cases get into the seconds or milliseconds of operation. All of these capabilities are ultimately needed to ensure that we can go from a world without consumer energy resources to a world with consumer energy resources. And if you think this looks like a lot, it is a lot. And ultimately, that's why the distribution networks in particular are really key partners to support the transition. One of the things that we're doing a lot of work on at the moment is thinking about how we actually provide innovation platforms to support this. So thinking about new ways of providing visibility. You'll hear a lot of talk around dynamic operating envelopes. This is a capacity management technique that we've been working on for the last 5 years, which is now thankfully been taken up by most of the networks, or all of the networks in Australia. Some of the other capabilities which I think really talk to the role of technologists in the ICT sector is to think about all of the interstitial pieces that we need. It's very easy to say we need the poles and wires, and it's easy to understand we need all these assets connected to the poles and wires. But to achieve this orchestration that Simon was talking about, we actually need a set of capabilities which we would think of as called grid integration capabilities. It's the It's the metering, it's the software, it's the systems that allow you to collect data, to meaningfully use that data to achieve the goal that you want, which ultimately is to achieve energy reliability, energy security, and resilience. And resilience is an increasingly important piece, obviously, as we start to think about the effects of climate change, which are increasingly making it more difficult to actually operate our energy systems. The last point, and then I'll get out of here and hand over to Lynn. We do spend a lot of time at the moment focused on the electricity system, and there's good reason for that, because decarbonisation is going to be driven by electrification. But at the same time, one of the things that's happening at the moment is that because we are interconnecting all of these other pieces onto the electricity system, we now need to think about these as integrated energy systems. And so your average customer does not care about this, but they will care about this when they can't plug their EV in and charge it when they want to. And so ultimately, it's critically important that we as a sector think about how we understand integrated energy systems. And what I mean by that is how the electricity system supports the transportation system, how, hot and cold, heating and those flows actually work as integrated into the electricity system, how we transition off gas, how we support hydrogen, et cetera. We're at a point of convergence there. And so one of the things, again, work that we're doing is thinking about new ways of modelling this. And so what you can see here is just a snapshot of some work we're actually doing on our campus at ANU, which is actually modelling all of the integrated energy systems on campus and using that to actually work out how we decarbonise and move off gas. And again, I see these as kind of critical opportunities when it comes to thinking about new capabilities and technologies that all of us might be interested in. I'll wrap up there, and obviously looking forward to the discussion and any questions that arise during then. Thanks very much.
Thanks, Lachlan. That was fantastic, and looking forward to getting into some of those things on the panel. Next, we have Lynn Gallagher. Lynn was the CEO of the Energy Consumers Australia until recently, earlier this year, and has now joined the board of the Australian Energy Regulator, which is tasked with sort of regulating the whole industry and administering the rules, but has a particular focus on what the networks do and how they are able to raise money and what they charge us. Interestingly, it's a time when the role of the AER is probably changing, and the consumers are now participants, and looking forward to hearing from Lynn about what she's doing and talking further about what that means for the rest of us.
All right, good morning everyone, and I'm very bad at slides, so I don't do slides, so that's not a dig at my colleagues because I love their slides actually, I just hate my own. I also want to pay respects to the traditional owners of the land that we're all on today, and where you all join us from online, and acknowledge the importance of their connection to country and culture. I'm going to sort of speak a little off the cuff, so if it doesn't sound that polished, I apologise. But I really just want to, I think, having heard from Simon about, what the system looks like, what the distribution challenges are, and from Lachlan about how we might go about doing this transformation, decarbonisation and electrification, I want to talk a bit more about, or a lot more about, why. I'm really glad this session is titled A Consumer Grid. It always was a consumer grid to a consumer. It's the thing that connects us, and I've seen Lachlan's interface before, and it is the best human interface to the bulk power supply system that we've ever had. But, people see, ask anyone who grew up without electricity what the power of having electricity is, how transformational it is to your community, to your lives, to your businesses. But we're shifting from that bulk power supply system to one that's distributed and local, which Lachlan's talked about. The mindset shift we haven't made is traditionally we always thought about what was behind the meter and we called it behind the meter, stays behind the meter. We don't much care about what happens behind the meter. You just tell us what you need and we'll just give you that quantity. Now we're flipping that, but consumers didn't get the memo, right? What they're actually sort of being offered is this supposedly utopian future where we're all monetizing our consumer behavior change. Again, I'm not having a dig at anyone, but you know, a car is a car, right? A car is for mobility, right? We don't much care whether it's a battery on wheels or, you know, we want to charge it, we want to take our kids around, we want to use it as a fleet if we're a small business. So again, it's same problem, different framing, right? I mean, there's no doubt these are the huge challenges, and we do not want a third world electricity system. We want to go from a carbon-based first world electricity system to a renewable-based electricity system, and we're doing it at a pace that has never been done. And we are inventing the science, but I'd also say we're inventing the social science, right, about what do consumers want. Consumers want a better future, not more of the same pain, right? And arguably to them now, they're experiencing more outages, more weather-related outages, obviously, not because of failure of the system, and it's never been more expensive. So not since we generated electricity at a municipal local level has electricity been this expensive. So from their point of view, the sort of wonders of decarbonisation look like a hell of a lot of risk to them. It all involves them doing something. If you imagine replacing all your appliances, gas appliances with electricity, replacing your vehicles, and imagine that's something like a cost of $50,000 per household or something around that over time, obviously, that's $500 billion. So replacing all our generation is estimated to cost around 300 billion. So we're actually asking consumers to also there's going to be calls on their resources in terms of investing in these assets. And that, you know, could include a solar system as well. It could include a home battery. So it's not far-fetched to think we're looking at an investment of consumers in the future of $500 billion. What is less talked about is in a renewable energy world, it is going to require some adaptation from consumers. You know, strangely as people, we use more energy in the morning, or most of our energy in the morning and the evening. We don't use our energy during the day. Small businesses mostly use electricity during the day, except if they're in sectors that serve people, you know, restaurants, you know, hospitality, all of those kinds of things. So we have a high demand for things that meet, you know, when we're home, if you like. And if people make heroic assumptions about who's going to be home and if we're home all day, won't it be great? You know, again, it's what adaptation can humans make around their lives and how they run their businesses that is actually going to match their needs for electricity to the availability of electricity, which is going to reflect the availability of wind and sun. And we know that it's variable. So that kind of adaptation is going to be enabled and empowered by technology, by data, but essentially we're going to have to be informed about what do consumers want, what are they willing to adapt to, what control do they want? And again, I think a lot of the conversation tends to be about what we can do, but what should we be doing? What could we be doing? How do we make it a truly consumer-centred future? Do you imagine that, you know, again, if I take Lachlan's example of the light switch, you know, no consumer ever probably said, isn't it fantastic that remotely you're going to turn that light switch off and on all day, right? I mean, you know, in theory, if we want to actually use the flexibility or some surplus energy that people might have in the house when they don't need it, or maybe they're willing to turn their temperature settings down, but what we're actually saying to them is we're going to turn that light switch off, up and down, and you're going to love it. Well, I'm not sure that's actually how people feel. So where I'm going to end up is one of the things that I am working on as part of a big group of people across the sector is the idea of having a living lab in Australia, where you actually have households that are willing to participate in technology trials or various other trials about what's possible, what's desirable, what's plausible, what can be done at scale. They use these overseas, they have them in Europe, they have them in the UK, and I don't think we can plan to do decarbonisation of 10 million homes and 2 million small businesses without actually having real lived consumer experience informing the design of what we do with technology controls and with the system. So I'll stop there.
Thanks, Lynn. Lots of insights there. I'm going to ask Lynn and Lachlan to join me up the front in the Dave Allen chairs. I did ask David at the back if he'd be kind enough to come up with a whiskey and a glass of ice, and I'd shorten my finger, but we haven't got that far. Simon, you might have to take yourself off mute, and that should, if you tap your mic or something, should actually bring you to full screen for this end. We're going to canvass across some of these questions now and talk amongst ourselves for a bit, and then we'll take questions and answers, questions and perhaps answers from the floor as well. I actually might need that side table for all my bits and pieces.
Just work backwards. I couldn't see there for a moment, but I can see you now. That's good.
You've got us? Good, okay.
Yeah.
I might sort of work backwards given which where my folds and things are. Lynn, always the consumer grid. There's a lot of gentailers who think that the networks are there to service them that would probably disagree otherwise. Is that one of the interesting changes or where we need to think about where we start from?
Yeah, I think that's right. I mean, if you like, the design of, or the business model of how electricity is sold to consumers, and if you like, the way electricity is delivered to consumers has not changed in, 70, 80 years. And in some ways, maybe that wasn't a problem for the last 80 years because we actually weren't, electricity got cheaper for 50 years, every year until 2007, right? So really, we weren't asking consumers to think about electricity at all. Flick the switch, it's on. It was becoming more and more affordable, and now it's not, right? So I often hear retailers say things to me like, well, we own the customer. And I think those kinds of attitudes, those kinds of approaches are really going to need to change. But it's challenging us all. It's challenging every part of the power supply system to think about how do we actually make this easy, convenient, simple, intuitive, and as I said, it's got to be better, right? And it's not actually going to be much more affordable, right? I mean, prices, when you have this kind of level of investment in terms of the power system assets, the 50% that Lachlan's talking about, prices are not, they will come down, from where they are, influenced by Ukraine. So what we have to do is actually create the means and opportunity for people to use electricity when it's cheaper, when it's more abundant, when it's available. And I just remind people, not everyone has a driveway, not everyone has a garage, not everyone has a roof, and not everyone owns their home. So a third of people are going to be in apartments or renting, and we can't have two systems, one for people who have technology in their home, and one for people who don't, and a very wide divide between the affordability. So again, I think it's challenging us all, is really the way, Tim, I'm saying it. The future is not the same as the past.
Can I add to that?
Absolutely.
So I'm feeling controversial this morning. Yeah. So I'd maybe go further and say that if you think about the pieces you actually need in your energy system to get electrons to people, you definitely need the networks because you need the poles and wires. But there actually is a legitimate question as to whether you need retailers in their current form. And And I say that not so much in a disrespectful way to retailers about saying they should disappear, but in saying they do actually need to evolve in order to actually have a proper relationship. So I agree, they don't own the customer, they're holding the customer hostage because the design of the system requires you to have a retailer to actually be able to connect to the grid. But there's no reason really that that should be the case. And I think in the context of discussions around new technologies, there are other ways that customers could and probably should engage with the system. And so thinking from a retailer perspective, I think the call to arms is to actually think about how they become retailers fit for the energy system that we're now building, and that will go to supporting household and community ambition. It will go to, you know, leveraging appropriate technologies, but also ensuring that actually costs trend to be much lower than they are. And if you break down, you know, a customer bill, you actually see that there's still a reasonable amount of margin that could be trimmed out of what most customers are paying for their energy today.
Simon,
Tim,
would
can
you
I
like
just...
Yeah, I was about to say, I'd like you to get in first because these two have given me a segue that can light a fire. So you can either you can pour some fuel on it or tame it down.
I'll give a good example. Oh, I've got a bit of an echo with you guys because I can hear myself back. Is that fixable? Anyway, we'll continue on. So to Lynn's point, it's a very good point about that. If you think about the split across our community, if you're in an apartment or you're renting, you kind of don't have a lot of choice. If you go the other end of the spectrum and you own your own house and you can put solar on it, and you've got the capital to do the things. And I'm living that living lab. So I use me as an example all the time in my own organization about what the future might look like. Because I have PV on the roof, I have a stationary battery in the house, I have an EV, I have smart charging, and I charge off excess renewable energy when it's exporting, right? But what that means from a retailer perspective is I don't buy electricity anymore. I end up buying less than half a kilowatt hour a day on average. And I export most days, even with the car. And and it's only sort of in winter, and it's only during sort of cloudy days for 3 or 4 days that I'm really impacted. So from a customer perspective, I'm the worst customer under the traditional retailer model because I don't buy electrons. So we've got to recognize in this new future system that the whole thing was built around selling electrons to people on a one-way stream. The reality is the future energy system, large sections, particularly of suburbia and commercial industrial, will need the security of the electricity network, but their product that they're going to buy from some entity, whether it's a retailer or not, is not really electrons, but it's almost like insurance, right? You're connected to part of this bigger ecosystem for a capability or good, but it doesn't mean that, because you're making the product yourself most of the time. So I think we've got to really look at this and go, what is the, and that's a bit philosophical, but what is the electricity network and what value is it bringing as a community? And that's very different to we're just selling electrons, because a portion of our society is not going to do that anymore.
And I think it's a really good point to make about the grid not being a source of electrons, because it actually talks to the possible different models that we might head towards. And so I do think, you always have to be careful with analogies, how far you can stretch them. But I do think, again, the telephony one is an interesting analogy to look to. When we first got mobile phones, we were charged for volume. So you were charged per minute or per 30 seconds, you were charged for every text message that you send. And we pretty rapidly evolved to the point where you simply pay for access. And what you transfer over the mobile network is not actually charged anymore. And so in thinking about different ways that we might be able to head, there is no reason why in this future world where you have all of these assets and you are orchestrating them to operate the system most efficiently, that we may actually move to, mobile phone style plans where it is an all you can eat, but effectively people and householders, short of running hydroponic systems in their basements, actually tend to consume what they need rather than being like outrageous users of energy. So I think it's just, there are lots of models in other industries that we can look to. And again, the energy industry tends to be a little myopic and tends to look inward a lot to see what we can do. And actually, the purpose of the forum today and the previous, fora that have been held is actually, I think, to think about other industries where the energy system could learn from.
So many segues, everyone. Yeah, and it's a crucial part of it that we need to understand what that change is. And so if we take the Netherlands, for example, the Netherlands customers there have a relationship with their network and a relationship with their retailer, and they're independent. And I have I suppose, a perspective of understanding of saying, I think with the fact that distribution we did have a vertically integrated utility system, but distribution is now decoupled. The capacity of generation was linked to transmission capacity, was linked to distribution capacity, and it was all a design system to optimise around it, where things like domestic hot water off peak, etc., was all around managing the challenges of trying to get the generators to slow down. It wasn't really to be magnanimous to consumers for cheaper energy. So we've got all these things changing, but at the moment we've got a lot of other problems and a lot of people that are trying to put these consumer energy resources out there, or talking about EVs or batteries or whatever that go with it, tend to be very focused. The sales model tends to be very focused on avoidance of network cost recovery. And if we're going to the subscription model or the service that goes with it, if I could ask the three of you maybe to teleport yourself to 2033 or 2035, I'll be 78 then, so I hope I'm still here to see what it's like and come back. That's speaking from someone who's there, nearly there. So if we think about that, how do we get to that challenging issue because at the moment, all the gentailers do everything they can to stop any sort of tariff reform, because the existing model, consumption volumetric tariffs, are built around protecting their monopoly, or not their monopoly, their customer base that they think they own. When would you like to go first?
Oh, great. My special subject, as some people know. I'll try not to go into the sort of nerdy version of tariff reform and keep it simple. I think the problem is because we've structurally separated retail from networks, they've been in an unholy war ever since. In a way, the simple model, we were in a buy electrons world, and who were the sellers, who were the interface, who were the people you dealt with? They were the retailers. And lo and behold, they actually also own a lot of generation assets. So their incentives were to keep us in a buying electrons world. If you step back though, and it's a good way to think about it, Tim, which is how I often try and get out of the here and now and try and figure out what's the destination. Lachlan's absolutely right. From the point of view of using the distribution assets or the grid assets, it really is going to have to move to some kind of access pricing, or using the capacity, and it doesn't really matter what you run over it, and when you run electrons through it or not, whether you're supplying them or buying them. The difficulty for Australia that is the fact that we have a long interconnected system with low density customer base. So the cost of that access per household, per customer, if you like, is really high. And therefore it's regressive. And I'm not saying today is okay. It's not. There's lots of transfers between different customers. Solar customers are able to avoid, because of volume, charging by volume, can actually avoid paying their actual cost of the grid on a capacity basis. So we're going to have to deal with this social issue of regressivity and how we actually get from where we are to there. So it's not easy, and it's always been problematic in communities because the people who are currently benefiting from the system are well organised, usually own solar, usually own batteries, and write academic papers and letters to the newspapers saying, by no means should you be making us pay any more because we're saving the system.
So I think, in any set of rules, organisations will optimise the best outcomes for those set of rules. And so it shouldn't be surprising to us that, given that we have a set of rules that, for example, gentailers or retailers under the current set of rules have worked out how to optimise. And I think it's appropriate for us to challenge the outcomes that have arisen from their optimisation, but to recognise that actually they are currently operating within the rules. So it's not to say I like the outcome that we currently have, because I don't. But I think it's important to recognise how we've got here. And to be fair to them, they've not actually acted in a nefarious way. They've just worked out what is the best way to act under the set of rules and incentives they have. Going forward, this will change simply by the fact that coal-fired assets won't be in the grid by 2035. If you look at, 5 years ago, when we were talking about when coal was going to exit and where we are today and when coal is going to exit, it's come forward massively, and it's come forward not driven actually by government, but driven by the operators, who realise that their assets are ageing and not going to last the lifetimes that they thought they would, and particularly given the variability in climate that we're now experiencing, are actually facing quite significant outages. So thermal assets will come out of the grid, and that will change the dynamics, because there will be different owners of new generation assets. When you come to the tariffs around networks, though, I think ultimately you have to sort of take it as axiomatic that the networks play a crucial role in connecting all of these assets together and providing us kind of energy reliability and energy security that we actually do all value. And it's right that they are regulated, and they too will try and optimize within the incentives. And so hence Lynn's job is to make sure that we, we modify the incentives over time to ensure that we're getting the best value we can out of the network assets that we have. And so one example of this is that, a lot of network infrastructure, isn't running at 100% capacity at the moment. And there's very good reason why it isn't, because we don't have the safeguards in place to operate it, at that capacity. But to what Simon was talking about, we are now moving to a world where we're looking to access and to use much more of the available capacity, so we can actually do a lot more energy transfer over the existing poles and wires, rather than sort of needing to massively invest. So I think, these are hugely complex questions, but we actually are on the right trajectory to solving a lot of them, because the older technologies that have become incumbent under the current set of rules are actually leaving the system and will be replaced by new technologies, particularly consumer-owned assets and household-owned assets or community-owned assets that we can actually now choose to operate for and on behalf of people in the community.
Can I just add one thing to what Lachlan's just said as well? That capacity utilisation point is the real opportunity, the real gift, right? There's a lot of, what you might call headroom in the existing distribution system, in that it's only operating at maximum 11% of the year. The gift that we're getting is electric vehicles. So if we establish community and social practice and behavioural norms for consumers that enable them to use their car as a car, but also charge outside of peak times, then you're utilising that capacity, you're soaking that up, and it's existing capacity, and every addition to capacity is also better utilised. So some modelling work that Energy Consumers Australia shows that you can really bring down the costs of networks, the charges for networks significantly by accelerating our uptake of electric vehicles and utilising that network capacity. So at the same time as we've got all these factors pushing the cost stack up, electric vehicles are an absolute positive and a gift we've never had. So I think that's where some of it enables the shift in rules and shift in behaviour and shift in acceptability of different tariff design.
Just before Simon jumps in there, Lynn, and more as a aid to memoir for later, we need to think about, we're almost lucky that we're late to the EV party, because the smart charger is out there that can be timed, can be remotely authorised to operate at certain times, can be priced independently. So there is a real opportunity for social and economic behavioural change around that charging behaviour But we've also got to make sure that people just don't go and buy granny chargers from China and things that don't work and all those things as well. So we have to think about how those operate. But we'll come back to that later. Simon, would you like to address the first question of jumping forward in time?
Sure. Well, the good news is that's my day job. I get paid to think about what the future looks like, go into that future, and then try and bring that back to the organisation, which is a pretty unique position to be in. So we've actually just recently been through an exercise to look at exactly this situation, Tim. And one of the challenges around tariffs is that we try and get them to do too many things. So on one hand, it's how we get our money in terms of we've spent money in the regulatory process, and it's just the recovery process and how we effectively charge customers to get that money. But then we also try and turn it into a kind of a behavioural control scheme where we say, if you have this sort of network tariff, solar soak's a really good example, but the mechanism doesn't work because the customers never see the behaviour because the retailer, smears it and doesn't want to have those sort of difficult price signal discussions. The other challenge is that, to a certain extent, tariffs are a social construct. So we're trying to have a relationship with all our customers in the same way with a distribution network. But the reality in the future is that you will have, I suppose, different classes of customers in terms of their impact on the network. So if, again, I'll use that home owner arrangement where they've got a smart home and they've got all the bells and whistles and they really don't buy electrons. In terms of our network cost to serve, that's really low because in the end, we're never really augmenting the network. We're never expanding or growing the network for their needs. So do they get a better deal from a connection, to Lachlan's point about their sort of what your monthly charge is going to be? Do they get a better deal than somebody who needs a significant connection because they've got, a big air conditioning system and they don't have solar on the roof and they're in an apartment complex? Or do we have a more sort of socially equitable, everybody pays an amount irrespective of how you use it? I think that was the challenge that we looked at. And look, I don't have an answer to that. And I think it's not the distribution network's place to make those decisions. It comes back to our customer, our CAP groups and these sort of things to say, what would society, what does the public want to see from their distribution network? But that future world will change purely because the way we use energy will change. Hope that kind of answers the question.
I think, Simon, that's a really excellent point actually around the sort of asking tariffs to do too many things. I think maybe it's probably worth just drawing that out because the system actually does this in lots of different ways as well. It's the same reason Australia is one of the few systems in the world, particularly on the East Coast in the national electricity market, that actually has an energy-only market. So most rational electricity systems globally have both a price for capacity and then an intraday price for managing shortfalls of energy, which actually tends to stabilise prices. So in Australia, we're trying to use just the spot energy price to simultaneously incentivise entrance to the market as well as achieve intraday optimization outcomes. And then to Simon's point, we're doing the same thing with tariffs. We're trying to say, here is one tariff. We want this one tariff to actually simultaneously do cost recovery and also optimize how we operate. And I think one of the opportunities that we might look to, particularly on the distribution network, is to think about the fact that humans don't really respond in the way you need them to tariffs. Surprisingly, when I go home, I don't check the tariff before I cook dinner, and most people don't. So thinking about potentially having different tariffs for people and machines. So we're going to connect something in the order of, say, 10 million consumer energy resources and maybe another 10 million electric vehicles, maybe 20 million electric vehicles. They mostly will come with systems that can be automated to respond. So what is the appropriate dynamic tariff potentially, or the set of constraints or limits that you can apply for a machine because it can respond very, very quickly in an automated way versus the simple tariffs that people need to respond to. And so thinking about that is actually, I think, one of the interesting opportunities that we've got around tariff reform.
So that gets onto one of my sort of favourite topics, is the separation between essential and non-essential loads. You expect to be able to cook your dinner. You expect to be able to turn your lights on, whatever it is. There's certain things that are essential, that are normalised, that we really want to use. But there's a lot of things that are flexible. It's not the same for everybody, and not everybody has to do it. You can do something as simple as putting your dishwasher on to go on after 10 o'clock rather than immediately after you finish dinner. You know, they're the simple things because you really want clean dishes the next morning. So when we talk about machines and flexibility, that brings us into dynamic operating envelopes and where that fits in, because that's a capacity management tool to tell people dynamically, real time, that there is capacity in the network that they can use. So this is where if someone has a subscription, like we do with our phone, and there's capacity, I can pick up my phone and use it as much as I like because there's a capacity available in the network. Some of us have limits on our amounts of data and things as well, but you've got to subscribe to guarantee and then things that you can do over the top of it. And I look at those opportunities. You said the prices for machines, but at the moment, our network tariff structures and the way they work are very, very coarse. Like a lot of people are just reasonably happy with the idea of a flat tariff, let alone going to time of use, let alone something that could change really dynamically. But if we think about it, everything else, every other thing that consumers buy, they go into the shopping centre and they look at the price tag and it's 2 for 20% off, or you pay full price, or it's 20% off your 6 bottles of wine if you don't buy 2. Whatever those things are around that storage and management. How do we get, I suppose, that understanding of people? Because I genuinely believe that people with solar and batteries, or using community batteries with their solar or whatever, or their car, can really save money out of having a good subscription tariff service for the networks managed by DOE. So if we've got benefits to the people at the moment that are avoiding the network charge, and we can show them the benefit, how do we bring that along if the retailer's the only communication to it and they're the ones that are going to sell less electrons and sell whatever and don't want to have any bar of it?
Yeah. Maybe I might kick off on the DOE front. So dynamic operating envelopes were a concept that were essentially proposed through the Evolve project, which was a project that ourselves, a bunch of the New South Wales and Queensland networks, and a bunch of the Australian aggregators undertook, kicking off in 2019. And so the background to the dynamic operating envelope and where the language actually comes from is that I'm actually an aero engineer by training. And so as soon as batteries have wings, I'll be the happiest person on the planet. But aircraft have a concept of an operating envelope. And the operating envelope is defined as the point where you pull back on the stick and the wings don't come with you. And that's typically a bad outcome for your average aircraft. As my design lecturer used to say, it's like, that makes people unhappy. And so what we were trying to capture in the concept was the fact that actually there are physical limits within our system, and these exist simply because transformers do have a thermal limit. You can't transfer an infinite amount of energy through them instantaneously. We do have voltage limits to ensure that voltage stays within the prescribed limits. So the goal was really just to communicate, or to be able to calculate first, and then to be able to communicate what those physical limits are, and to then encourage a discussion around what is an equitable division of instantaneously available network capacity, which then allows you to actually come up with what is the appropriate social response to a finite amount of capacity. And the other analogy you might think about is when you're driving down the street, you don't mount the curb to drive on the sidewalk because there is a traffic jam. So we already have these concepts socially where we say, well, sometimes there is finite capacity, there is congestion, and we have to deal with it socially. And so the whole DOE concept was around saying, let's calculate and communicate what the instantaneous capacity is, and then use that as a signal to think about devices shifting their behavior. And I think it's a really good point about the discretionary and non-discretionary energy use, because the DOE concept was never an attempt to say, at some point we're going to stop you using energy, because that's a crazy outcome from you built $200 billion worth of infrastructure to access energy, and you're going to shut people down so they can't use it. That's not the goal. The goal is to is to think about the signals and information that you can share with assets that are controllable and discretionary. And so things like EVs and batteries. And as it turns out, when you look at the analysis, what an operating envelope actually incentivizes in assets that are flexible is actually a time shifting of behavior. And because of the design of most tariffs, it actually doesn't impact the costs to the customer at all, because you have lots of periods of where the tariff is identical. So if you identify constraints, you can ask an asset to behave in the same way at a different time interval. So economically, it gives you exactly the same outcome from a customer's perspective, while actually ensuring that we never breach the physical limits of the network. So, I mean, to me, for lots of reasons which I'm biased about, I think the DOE concept is a good one. And I think it forms sort of one of the pillars of how we actually manage network capacity.
Simon, would you like to?
Sure. I suppose I've got a slightly different view of that, the concept of a flexible load versus, your cooking load. The concept is good in the sense that we're saying there are certain things that we don't want to take away from people. But at the end of the day, from a network perspective, that physical capacity limitation is a network one. It's at your connection point. So kind of what your little ecosystem does and how much technology and smarts you've got. It's the mobile phone example is a good thing. You can connect to our network and you've got so much bandwidth capability right now, whether you're streaming Netflix or whether you're making a phone call or whether you're, doing something else with some app on your phone, we kind of don't care. So as long as you're not, either exporting too much or pulling too much load that's causing us to hit that operating envelope and the plane crashes, I don't know that networks particularly want to get in behind the meter and start saying, we're turning that one on, we're turning that off. Some entity might. There might be an entity that's an aggregator, might be, some sort of third party thing, but I'm not sure that it's the role of the network to make the decision about whether you can and can't charge your car. What we should be saying is the network is now constrained at this point in time, and your overall consumption and or generation at the connection point needs to be within that limit. But if you choose to charge your car instead of cook your dinner at 6 o'clock, that's great. We don't really care, right?
And that's quite logical from a viewpoint that the envelope sets its constraints and say you cannot now exceed what you're subscribed to, the capacity to use that benefit. So we'll step back. Austria conducted a trial tariff where you could charge your EV at any time and not pay any network tariff for charging your EV, provided you did it at a time when the network was unconstrained. And they had a retailer on board that did that signalled to the charger that said you can or can't charge. A hard way of doing that was to actually turn the EVSE off, or the second way was, if you do it, you will pay the financial cost associated with doing that and recover penalty charges and things as well. So back to Lachlan's example of if someone needs to get from A to B, they can mount the curb. They can drive along that extra path, or they can go into the T2 lane or the T3 lane and pay the fine because they haven't got the tools and things that are able to do it. So I think, and Lachlan was involved in Reposit, and Reposit has done some really great work with Ausgrid on the Project Edith things around, which is a dynamic operating envelope environment where a capacity limit is set and then signals to say you can use more or less depending on never less. And that's one of the problems when people talk about dynamic operating envelopes for load, is it's not about turning people off. It says you come back to your subscribe limit. And I can choose as a subscriber to say, I want my subscription limit to be higher to reflect what my normal base minimum requirements are. But some people have no flexibility, in which case they shouldn't be penalised. They subscribe for the service and they're able to do what they need to do. Does that change perspectives at all for any of you?
I was just going to make some observations. I think, again, these things are all really important because what we're trying to do, what I'm hearing and I'm fully on board for, fully utilising assets, recognizing, time shifting and, where the flexibility in the assets and getting the full utilization is exactly what we need to do. Unfortunately, how it translates into the real world is that policymakers and rule makers are both bad engineers and usually bad social scientists as well. So we end up with these sort of very imperfect kind of arrangements that don't actually approximate. So it's how are we going to get these kinds of ideas plus married with social science and permit, what does society value and what does it want, and bring those together into the rules. I'll give you an example. It's an old limit in the Western Australian system, in the city areas, and I don't even know what an amp is, so just laugh at me if you like. But the rules are you can have 64 amps in the city and you get 32 amps in the country. That was never enforced, but then they actually imposed a rule that said, they changed the metering, or if you got solar, they actually changed the meter and they could actually limit you to 32 amps for the first time. And there's absolute uproar now that people have discovered that there is a two-class system in the southwest system of Western Australia. And so again, it's like, technical things that sort of made sense for allocating scarce capacity, and, there was a logic to why in the city you'd have more versus in the country. Well, now if we're all going to have EVs and more people in the country will probably have EVs, et cetera, then you've got all these social dimensions that are coming to the fore that we have to think about. The other last thing I also want to say is we cannot forget the built environment. Australia has almost the worst housing in the world in terms of thermal efficiency. We have a high tolerance. It seems to be national pride to be able to live in cold homes and homes that are too hot and that are inconsistent with human health. And people who rent are in the worst homes. And so a lot of these things also, for us to fully utilise assets more efficiently and the capacity, or how many assets do we need, are actually interdependent with the quality of our buildings as well, and particularly our homes. So again, if you want people to have some flexibility, and it's 45 degrees in Western Sydney, for a series of days, and they, their star rating of their house is closer to that of a tent than to the modern standard, then of course there's no flexibility. So we need to build more assets, right? So again, in a lot of this, we're having technical discussions, but it can often feel like there's the good consumer, the ideal consumer, and then there's the rubbish bad consumer kind of stuff who, has all these constraints. Well, we've created that, right? Energy was cheap, land was expensive, so we built rubbish houses.
It's a
Can I
real
just
problem.
Can I just
Sorry,
add to
go,
that?
Simon.
Right. And I think to Lynn's point about that, I'll call it two-class system, that's one of the problems that we have within the electricity network around engineers optimized at the point in time, some particular problem. So I like the concept of the homogeneous network is not the homogeneous network. That here in Victoria, it depends upon when your suburb was built, because we built either really skinny poles and wires because there was gas. But if you're a new suburb out, for example, some of the newer suburbs out west of Geelong for us for Powercore, right, they're built with a different set of standards on a modern thing. So yes, you can connect your EV really easily. We won't have any capacity constraints. And that's really hard to talk to the public about, because people go, I bought this house in this street and now you're telling me I can't do something, but my friend who lives in this other suburb, they're not getting the same constraint. I don't understand. And it's like, well, your poles and wires are actually different, because we, and effectively the word is we've underinvested in your neighborhood and we've overinvested over here. But the reality is standards have changed over time, and they changed, and each state is different. So when you look at what Queensland installs versus what New South Wales does, because of the state-based processes, we don't have a consistent electricity. It's like the railways, right? I always laugh about, everyone used to laugh about the fact that there was different gauges for railway lines. Electricity is exactly the same, that the standardization, isn't there. And so kind of it's the, and I feel for solar installers and EV manufacturers and stuff who go, well, hang on, I want to sell into, Brisbane, or I want to do something in, Sydney, I want to do something in Melbourne, I want to do something in Adelaide. And they go, the rules are different every time. Well, yeah, because unfortunately, there isn't a homogeneous approach to the way we do it. And I don't know we can solve that because it's big infrastructure, but I think we need to recognise that that's one of the barriers to success here.
And it's the same sort of thing aside from the houses like tents, as Lynn talked about. We look at the changes on energy panels and how houses are wired as similarly the same sorts of problems, and being able to expect those outcomes. And Lynn and I did some work 12 months ago or so with Westpac, trying to talk about the build environment and how funds can be allocated to try and drive these solutions. But at the moment in the mortgage world, they don't even consider in the valuation of a property whether it has solar or it hasn't, or what the energy costs of actually using are for a particular house. They do these assessments of can people have capacity to pay, but they don't actually look at it from the viewpoint of, is there a better capacity to pay with that house versus this other house? And if we're going to talk about time shifting thermal load, so we can actually pre-cool and preheat houses to affect how those loads work, the houses have to be suitable for it. And so it's not just an energy problem, it's a systemic problem of our build environment that drives that as well. And, when you talk to government departments and things around this as well, they're all in different silos. And we have these with the problems of and then when you get businesses, they're trying to do different things for themselves. How do we get this solution that is really for the consumer?
I think that point about the silos is an interesting one because, the government department that's responsible for housing and taking, social housing as part of that is very different from the part that does energy efficiency. It's very different from the part that supports electricity systems and the part that is looking at decarbonisation. And so I wouldn't always suggest we look to the US as a good example of how to do anything. However, one of the things that is interesting as part of their Inflation Reduction Act is that they've got a focus on basically getting houses ready for sort of electrification and transition through providing incentives, particularly around switchboard upgrades. If you've ever gone to a switchboard, they are non-compliant when you open the box, and they don't get more compliant when you install a new asset. And I've seen switchboard fires. And they're not super frequent, but they're frequent enough that, if we were to have a nationwide rollout of electrification of new assets, there's going to be really serious issues there. And it's going to look, pink bat style, because there's going to be a lot of non-compliant switchboards out there that get disturbed, and then ultimately something bad happens as a consequence. So, one of the things that would be good to see would be to recognise those foundational pieces. If we improve the fabric of all homes in Australia, we actually probably defer the major energy transition peak for years, because we would just have so much less load on the system. So upgrading switchboards, increasing efficiency in homes through ensuring that they're comfortable also has benefits through the health system as well. And there's been some interesting trials in the UK where doctors have been prescribing energy as a as a cure, basically, by paying for people who are living in poor housing to actually have a subsidy on their electricity so they can run heaters. And so you don't necessarily think of the health system as being a key contributor to energy transition, but there are obvious mechanisms by which we could do this. And so, I fully agree that the widgets are cool, and talking about energy transition is really, really interesting. But if we did the foundational pieces really, really well, we would actually save ourselves a lot of time and money and effort in actually achieving the energy transition when we get to that part of the challenge.
Can I just interrupt for a second? David up the back there, there's a Q&A enabled for all the attendees at the moment. I can't see any questions, and when I try to check to ask one myself, it comes back, it says it only goes to the co-hosts. But anyone out there, if you could please put in some questions and answers when that's enabled, and we'll come to questions in the audience and things in a second. Sorry.
I just want to, one thing, and there's a whole piece of, I could go on about this all day, but I won't. But I'll just plant the seed as well. Agree with everything Lachlan's just said. Decarbonising homes also involves creating a trusted, independent source of information for, all Australian households and small businesses. At the moment, we sort of rely on the seller of the kit or the electrician, and I think tradies are going to have an important role to play. But consumers need to go somewhere to understand what does the decarbonisation journey look like for them, for their home, and how they can get there. And so that's something that Energy Consumers Australia is working on. At the moment, it's largely, at best, it's crowdsourced, and there's a wonderful Facebook page called My Efficient Electric Home. But a lot of the time as well, it's the wisdom of crowds, but it's also, often you're socialising things that are not absolutely right? I mean, what might have worked in one circumstance doesn't work in another, but is held to be universally true. So again, it's this kind of allowing people to make the discovery, to make a plan, to have, to be able, you go out to buy your electric vehicle and then you discover that you actually need to rewire your house, right? I mean, all that kind of, all of these kinds of interdependencies. And we can't just assume this is all part of consumer discovery. I mean, we all have, lives to live, things that are important to us. And so we need to make this as seamless and as easy as possible, but it has to come from trusted, independent information. And right now, there's more information than people can process.
That's a really good. Yeah, go, Simon.
Can I just add to that? So it's a really good point, Lynn. And we've had that discussion within my organisation around that networks traditionally wait for the consumer, small or large, to come to us and say, I want to do this. And then we go, yes or no. What we should be doing is actually going, if you go down this path, here are the things you should think about. Oh, you want to put solar on the roof? Have you thought about this? Because we are the regulated body and we are the trusted source, particularly in the rural centres like for us in regional Victoria. So I think we do have to step up and provide more of an independent view. Even when it comes to things like microgridding for commercial industrial, we need to be saying, look, go buy some products, but here is the things, the questions you should be asking your installers and the product vendors. These are the choices you can have. This is how it best fits in with the electricity grid today. Like, we've got a better, I think, a bigger obligation around how we provide that information to the community. That should be what we should be doing.
That was actually the point I was going to ask you about that you just answered.
Perfect.
Because David Coote, who I think is probably online, asked a similar question of us both in a LinkedIn thread yesterday or the day before. And he was talking, or brought up the issue of people buying things at different stages and different installers telling them different things, or services, or salespeople. Has David got his hand up or something there? That can you see David Coote on that list there? No, don't worry. But okay, so leaving that aside, then there is a really important factor there that says the networks need to be able to have the ability to communicate with their customers. And at the moment, they're, I won't say prohibited, but there's no facility to do that because the retailers are the ones that are actually in that place. So how do we fix that? How do we change that challenge or that conversation?
I mean, I think, the networks and the retailers are not the only people who can talk to to people and communities. And so, I mean, one of the pieces of work that I know our team's been doing, actually in conjunction with Energy Consumers Australia, has been around thinking about honest brokers in all of this, people who are there to provide trusted independent advice, but who are not at the end of that trying to sell something to people. And we really don't have many of those resources available at the moment. So, I mean, to me, this is not to say that we shouldn't support networks and retailers engaging with customers. I think there's going to be quite a lot of work needed for people to want to talk to networks and retailers because the trust levels are so low at the moment. But probably, the additional piece I would add is that if we can find a way, to actually introduce honest brokers or, a source of independent information into the system, that would actually be incredibly valuable for people and communities.
Do you think networks are as untrusted as retailers? No, sorry, just to explain my position on it is, when the power goes out, when the cars hit a pole, the possums got electrified, whatever it is, the storms drop the lines down, it's the blokes in the high vis and girls that come out, that put our lines back together, that put our services, we see those and see those around in our community doing things, where the retailers, dare I say, the unfortunate party that's just sending us a bill, and we see the sticker shock and things around it. Do we distrust it? I mean, a lot of people think I'm a bit of a sycophant for the networks. I'm not. I expect a lot of the networks, but I think there's opportunities there that we're just not exploiting, and I do think people could trust them.
Yeah, I mean, it's an interesting one. Most people have a relationship with their retailer, like usually one of dislike, and particularly every quarter when you receive your electricity bill or your gas bill or whatever it is. I personally, I think the networks play a crucial role, and I mean that goes to my earlier comment. I mean, we don't have an electricity system without a distribution network, and I'm definitely of the view that the distribution network represents sort of the electricity superhighway when you think about adding in all of these, consumer and distributed energy resources. It's probably a question of if the networks want that relationship, though, because in some ways there's a lot of things that the networks can't control. So they can't control retail pricing. And so, I don't know, Simon, you can probably answer this. Do you want customers kind of calling up and like complaining about their bill, or do you want them calling up and saying, I'm thinking of a battery, can you run me through the 64 choices and let me know which one's best? Or is there a better organisation that can actually support customers in actually addressing the questions that they have?
I mean, to a certain extent, we want to have a closer relationship because it means we can provide a better service. Right? Like, so again, if you go back to that, what I said at the very beginning, right? The current model encourages us to treat the customer as a connection point. We really want to make them part of our ecosystem. So for us, that means that we need to have a closer relationship in some shape or form with those customers. And I think to Tim's point about the how we're trusted, I mean, we do a lot of surveying. All the DNSPs do a lot of surveys and engagement studies with the community to see where we sit. And I think what you find is that those things like storm response and the field crews are highly, particularly in rural and regional areas, that's a very high trust level, right? But where we come unstuck is we're very bureaucratic and very procedurally, almost government-like in the way you interact with us when you want something done. So you need, a new connection point, or you need a pole moved, or like we have a process for everything, right? But it's not a particularly efficient process. So from that perspective, I think people's interactions with us is very interesting in that when I really need electricity and you need to be there because it's an emergency situation, top job distribution network. When I deal with you on a day-to-day basis and I need a connection because I want to put my solar on the roof, or I want to move the pole outside because I'm putting in new subdivision in, they're the things that I think we get frustrations with because we're not particularly customer centric in our thought process. We're very network centric. So it's an interesting perspective when you think about how we do that. And a lot of it's got to do with data, right? So this is probably, I don't know, Tim, if you want to segue into this, but one of the challenges, of course, is you have the whole issue about privacy and what we collect on customers and how do we hold it, and the legal and social obligations. So from that perspective, there's we'd like more information to be able to better serve you, but we're also conscious of how do we get that information, because we're not your retailer, we don't have a commercial relationship with you directly. All those sorts of things make it a bit more challenging as well.
I mean, Lynn, I was talking to the sentiment, but I mean, ECA did a huge amount of sentiment analysis.
Yeah, so look, I think the simple way to sort of think about this as well. So Lachlan has one of the biggest social science teams as part of his program, but ECA is probably one of the biggest interdisciplinary sort of behavioural insight, social science focused organisations. The answer really on the sort of sentiment side and what consumers think is they hate all of us, right? They hate it, they don't really care, right? I mean, you're a network, yeah, right, hate you too. What is a network? Remind me again, we've done focus groups and people say, I don't want to change my retailer, and you go, why not? And they go, because my retailer keeps the power on, and if I go to another retailer, then I'll have more outages, right? So from their point of view, how do they feel about the sector? They hate us all. They think governments are asleep at the wheel. They actually, don't think much of energy consumers. Australia, when I'm advocating for things like export charging for their solar, so the trust issue is sort of a general one that we all have to keep in mind in everything we do. We need to be rebuilding trust and confidence. I do think there's a difference between retailers doing a better job in the service they offer and networks doing a better job in their business and being more customer focused and business focused. But it's not the same thing as actually Lachlan's used the word honest broker. I use the word energy trust, or the concept of an energy trust, because I want to use the word trust, which is I'm here for you. I'm here to understand what your objectives are, what you want to achieve, what your means are, what your constraints are, how can I make your life better and easier, and how reliable am I? And no one's going to trust a billion-dollar business that they're actually there for you, and they don't even trust, probably with good reason as well, solar installers or anyone else that's maybe, in fact, the people they do trust is tradies, right? So again, we're going to need to gear up and train up our tradies, right? Because at the moment, people, when an electrician walks into your house or a plumber and gas fitter walks into your house and the consumer says, what should I do? What's the quality of the information that we're getting today? And, the tradies are answering the questions as best they know or from their own experience. But is it the right information? Is it going to help with the transition, the transformation? I'm not sure.
I think it's problematic. Simon, I might have to ask you to co-host a bit here. We've just determined that my login here wasn't enabled as a host. So I can't see lots of questions, but you should be able to see all the questions that have come so far. If you have a bit of a look through...
Unfortunately, I'm in the same boat because I can't, hang on. I got nothing. The Q&A box is empty. I've got questions coming through now, and Dave, if you could work out maybe what the other option might be, and I'll go from there. You'd like a question?
Yes, please. Look, thank you very much, Tim. This has been absolutely fascinating. I've just wanted to jump in at every step of the way. It's been a real problem biting my tongue. And I'd love to come back and visit your contention that you're the worst consumer out, Simon. I would say you'd turn that on the head. You described yourself as turn it on the head, and it exposes possibly another approach to what you're doing. But I guess where I'm really going, and Simon, we are piloting behind the meter home automation, home control of energy for consumers. But we're too scared to take it mainstream for many reasons. But what that's leading me into is Lachlan's statement a little bit earlier that the signalling, the consumer doesn't want to look at a fine-grained signalling. Effectively, I'll probably summarise what you were saying there. We did a study a while back, and the pricing mechanism is in fact a very, very effective signalling method, but I agree with you. Your consumer doesn't want to go and look at the price of electricity before they turn their dishwasher on or something along those lines. What I would say is potentially it's the way of presenting that information to the consumer. So again, as part of our system, we have a green light, red light, where the light goes various shades of green and red, etc., depending on whether they're putting power out to the grid or whether they're pulling power in from the grid. And that's presenting a very effective way of giving them an idea of what their power consumption is. And in fact, well, I've been in customers' houses and the guy's wife shouted down, Gavin, can I turn the dishwasher on? What colour's the light? And, it's green, yes, fine, go ahead and run the dishwasher, sort of thing like that. So you're not necessarily looking at a sort of kilowatt hour or fine-grained pricing. You just need to give them a general indication of what on earth they're using. And which then takes me on to the next step. We were talking about dynamic envelopes and dynamic pricing, and possibly, are we ever likely to see dynamic pricing? I know there's a hesitation because the consumer's not going to look at it, but there are automation systems that could run in the home that would take in that dynamic pricing and very, very effectively optimize that power pricing for the particular home.
Oh, absolutely. I mean, to your point about the light signaling, those kind of mechanisms are very, very simple. I sort of, I was speaking broadly and I was being maybe a little cavalier, but I was talking really to the point of people looking at apps on their phone and so on like that. That I think is a bridge too far. The light one is, I think, a good one. And, I know in Queensland, there's a lot of new homes that actually have a light installed near, in the laundry, because that's a heavy, that's a point of significant energy consumption. So to the dynamic pricing one, it's interesting. Tim touched on it when he was talking about Project Edith. And so Project Edith does have a dynamic operating envelope component, but it actually also has a dynamic pricing component too. And yeah, it is quite effective because it's going directly to devices that actually can optimize and automate around that. And that really was my point. My point wasn't saying that we shouldn't have price incentives, but that we should actually delineate between prices to devices, which can be quite complicated because machines can automate it, versus the prices to consumers. And so I think what you've covered is actually quite a good summary of that, which is that you need simplicity for people and you need complexity for machines. And actually the combination of those two probably gets you a pretty nice outcome in terms of actually optimizing how the energy flows will stay within limits, but also ensure that everyone has abundant access to energy when they need it.
I'm just going to add, so they did do a dynamic pricing trial in California. They have a database of every price offered by every utility for every time period. And they're sort of trading the unders and overs. In other words, you sort of have a set point of the amount of energy that you want for your household, and you can, if you're underutilizing, it can be traded, et cetera, et cetera. So I think it's all possible, feasible, but it does run into problems every now and then as well, right? We've got to remember that these are households, not a single consumer, right? So often one person in the house goes, this is a great idea, but all the kids and the wife and everybody else goes, this is not a great idea. Do you mean like, I want to do this now, I need to do this now. So human lives are messy. I'll also talk about I do like the green-red thing, but there was an actual trial with, a couple of thousand people using green-red indicators. And what the kids did was keep making it go red all day because that was so much more fun, right? So again, it still comes back to what is the household dynamics around the use of energy, the need for energy, their lifestyle. There was another trial, not with green and red, but with a gamification. So the kids were actually learning to do things. So they started doing things that they were doing in the game, they did in their house. So they would close curtains, right? So again, it's sort of getting back to the human behavior stuff and permission and authorizing environment. So the technology is possible and can trade, micro amounts of energy, and that's all great and unlock that value. But you've still got to fit in within the sort of human, how we live our lives.
Can I just... I was just going to say, talking about some of the trials, this is probably the best example I've seen of a perverse incentive. So there's a retailer in the Australian market at the moment that basically offers pass-through on spot energy price. Yeah. And so a friend of mine, very, very savvy, so he's quite happy to price watch. He signed up to the retailer because he wanted to see what it was like. And what he does is that actually every time there's basically a vol price, so the price spike, which would otherwise, so it would cost him $15 a kilowatt hour to use energy at home. He goes out for a beer, and I thought it just struck me as this, like, it's completely not the sort of behaviour that we'd be asking for customers to follow. And he's someone who's, young, kind of has plenty of money. So going out for a beer is a perfectly acceptable solution. But if you think of that in other contexts, the vulnerable single parents, like, it's not an option to leave home with that price incentive coming through. So I think we do need to balance between, ultimately what risk we expose people to at the same time as providing incentives that actually do seek to optimize the outcome.
So that gets me to one of, I think, the biggest challenges. Nearly all these things that we have at the moment, everyone approaches it as a whole of load solution. It says, I've got the one light and it's going to be green or red or somewhere in between. And as a result of that, we're not seeing the things that are flexible, seeing true signals that they can respond to, because we don't want to have that whole price for it. Now, Amber, the interesting thing is when the price did spike because of the Ukraine thing and when the market was suspended and then coming out of that, customers that were on Amber made us a bucket full of money because they were protected on the consumption side by the insurance policy part of it that said they wouldn't pay more than the default market offer, and at the same time that they got all the export revenues and things around it. But so they had a perverse thing. Well, it actually happened that they were protected at that high level. But if we'd imagined that the default level was something that was there for just their essential loads of their services, so that you subscribe for that part of it and understand it. So do we see things out of the power of choice metering review, the ability for the meter to be a reference point, the ability for real-time data access being mandated by the AEMC to consumers? Do we see that as a way forward to open up the way the product of energy is offered?
Do you
I'll
want
go
me to-
first. Simon, you can go and I won't babble too long. I guess for me, it is that differentiation. So it doesn't surprise me. I mean, all of these things that we're thinking about have been thought about in the world, somewhere in the world before. We're not alone in that sense. We might have more solar per capita than other places, but so the Californians have created a thing, and they don't really care about how they do it with the technology or whatever, but they've created what they call sub-metering for electric vehicles. You could also think about whether you do it for hot water and other things, but I've got some issues with that. But it is that kind of thing where you can sort of differentiate between the things that you don't much care about, right? As long as the premise is my car will be charged, right? I won't lose charge or my car won't start when I next drive it. And the same with hot water. As long as when I turn the shower on, the water is hot and you're not controlling it in such a way that I get Legionellas from the system, right? So there's some sort of, undertakings, but I do think there is opportunity by separating it out, because there are other things like heating and cooling in the environment we're in, which trying to get some flexibility on a regular basis that you can monetize, I think, is wishful thinking.
Simon?
So I wanted to just take a step back to the question before, but tied into your comment about better information. I'll take a sort of an engineering physics kind of world of all this optimization and all this sort of like red light, green light, people making choices is because you create scarcity, right? So I've got a resource and the price is too high, I need to do something. And again, I'm going to use my sort of own personal experience. When I've got local storage like I do, I kind of don't care what the price is. I don't care what's happening in the network. I'm insulated from that because as long as I stay within the bounds of my system, do what I want to do. I never think about, I can't turn this on, can't turn that off, in terms of that process. But that's expensive infrastructure. Move it out to the community batteries discussion. If we had a slightly different mindset and said, we don't want consumers to have to make all these daily choices about turn this on, turn this off. What we need to do is time shift the energy. Something like a community battery, if we could make the model work and make it cost effective, would mean then that those consumers in the house wouldn't have to think about energy. they would simply do their daily lives and they're not impacted by all of this scarcity of resource. And I'd like to think as an industry, we start thinking about the consumer and saying, let's not make you have to understand this complexity of making choices about, do I cook the dinner now? Do I turn the TV on or off, and make these decisions, even if I've got the data to do so, but more about the fact that we enable what they do, how they live their lives, and we just recognize that there's some, I call it the slot bucket of energy, right? That's what a battery is. It's there to take the swings and roundabouts. We just need to find a cost-effective way to do it. Will data help that? Sure, it will. And I think your point about in the interim step, having metering information as the kind of the center of the home, so that at least the smart devices can be smart, is definitely the way to go.
Would you say a slop bucket or bubble and squeak?
Yeah.
So the opportunities are there. We've got another question from the audience here in the room.
It's been a really interesting discussion. I've really enjoyed it. I guess you could say I'm a bit of a devil's advocate in all of this. I've come out the other side, to put it simply. I've made some of the biggest buildings in the world fully automated, smart buildings, SCADA, you name it. I've gone all the way down that side, and I've come out the other side. And now, and I'm seeing this, I guess this is to you in a sense, Lynn. You said that there's this huge cost on the consumer in essentially replacing all of our devices. And I've started doing that 15 years ago. And now I'm actually going back the other way. I've had batteries and I've noticed that the planned obsolescence makes them die within 5 to 8 years. And so I'm now going back the other direction, going, actually, I want gas again. I want to be able to use a petrol device, which I know is going to be sitting there ready to use when I need it, not a year later when I haven't used it, the battery's dead and I can't charge it and I've got to go out and buy another battery. So, and I've seen this with a bunch of electric vehicles too, where a lot of people I've known that have bought them said, I'm never buying another one, because of the continued maintenance cost of it, and just you can't fix it yourself. So I guess the question is how do we combat that? Like, are we actually seeing the true value and benefit that electric's supposed to be bringing, or is it actually just shifting the onus onto the consumer to essentially buy more products more regularly, which is its own sense of non-sustainability? Do I really want to buy 15 of these devices over the next 30 years? Or do I want to buy one, which I know is going to work for a long time?
Yeah, I mean, it's a good point, right? I guess it's almost like the options are being removed, right? Tackling climate change, 20% of our emissions are contributed by the household and a large amount are contributed by vehicles. So addressing climate change takes away those gas and petrol options. I agree with you. Consumers are sitting there going, as we discovered in the Lismore floods, right? Or a colleague of mine had, multiple electric vehicles sitting in his house and then had to get a tow truck or a, huge mover to actually, once an electric vehicle has actually lost its charge and it's very heavy, right? Are we there yet in terms of the consumer utility? That's why I'm not a fan of talking about, it's a battery on wheels, it's amazing, blah, blah, blah. I mean, there are early adopters and, that's all very good. But in terms of, we're talking about at scale, so 15 million passenger motor vehicles, let alone fleets, 12 million gas appliances going to electric. Try and explain to my Turkish in-laws how they're going to cook Turkish food on an induction stove, right? So again, but we're going to these are the human problems we have to solve. It's not right to go, oh, well, suck it up, blah, blah, blah. Well, Indian food won't exist in 2050 or Turkish food won't exist in 2050, right? That the technology and the science is going to have to evolve, and it takes time, and the quality of it's got to improve. We're going from a mature system to a frontier system.
Yeah. What I'm saying is, even recycling batteries, 30, 40 years later.
Yeah, I think, Lynn's final point is one I think that's worth sort of focusing on, that when you go from something mature to something new, you get that early adopter experience. So I often describe myself as a troglodyte, even though I spent a lot of time building technology, because I've been an early adopter for so long that I'm just fatigued by being an early adopter. However, I have found a solution to this. It's just not to be an early adopter. And so, I think the point is that there has been a lot of hype in a lot of ways. And, we're all guilty of that. So like, oh, we've got a new widget that we've built and we want to sell. And so we're making big claims for quite immature technology. But I would probably argue that requires a different set of solutions than regression, because we can't continue to burn gas. And I mean, Turkish food is going to have to learn how to be cooked on an induction cooktop, because I'm not prepared to give that up. But, take the EV, I think, as a good example. Yes, if an EV loses charge, you can't move it. But if an ICE car has no petrol, it doesn't move either. Except that we have a lot of supporting infrastructure that means when you want to refuel your ICE car because you've run out of petrol on the highway, there's mechanisms to do it. So, NRMA at the moment is transitioning, for example, to being able to come and instantaneously recharge, but to recharge your battery enough to get you to a charger. So it's all of that supporting infrastructure that's quite immature at the moment that actually then supports you transitioning from that sort of early adopter phase to a more mature system. So I think we can't go back because, we're not going to have a planet if we do. But we need to focus on how we actually support and enable these new technologies to be robust and to be mature. And we can and we will get there. I'm very confident of that.
This is probably a good question that's enabled to segue to community batteries and energy storage as a service, a virtual NIMI in a community battery. So that joined with your NIMI at your connection point gets added together and it becomes just a buffer. And the consumer doesn't have to worry at all about whether it's their battery, whether it's connected, whether there's a problem with it, whether they've got to replace it, or any of those things, because it becomes part of the network infrastructure. And as people who follow me on LinkedIn will know, I rage regularly about consumers being encouraged to buy batteries when really there are better options with community batteries. But there's a lot of people who also want to be in the neighbourhood battery space, where we're now talking about the location of the battery and them trying to make money out of it as a business, rather than a community battery sitting there as let's say a slow transformer acting as a buffer. Simon, would you like to lead us off on that one?
Well, yeah, I mean, I think at the moment, the problem is that community batteries get what do you call it, neighborhood battery, but basically a generation and load source for time shifting energy in the street gets a bad rap. We've seen, it listed as it's a niche solution. It's not as mature as a Tesla Powerwall in the house. But a lot of that's got to do with, again, back to my point about networks. Every network has a different connection standard, has a different set of rules, has a different engineering expectation about how these things are installed. Until we standardize, we're not going to get the cost down. But if potentially half your battery, from what I've seen from some of the ones we've done in Victoria, if potentially half of your community battery costs are being driven by the way the physical device gets installed on the ground and connected to the network, then that's a really big area that we could evolve quite quickly. And then these things could be made useful. I mean, in the end of the day, there's an electrical engineering and physics issue about, load and generation that the street has to match. Then there's a second question of, like, as you said, the metering, the virtual NIMI, the true up of this much of this energy belong to me, which is what retailers do today. They're actually independent problems to solve, because one's just a data collection exercise and one's the actual energy piece, right? And particularly if that energy, like I keep telling people, if energy comes from the local solar panels on the roofs of the people in the streets, I mean, and I get that there's an infrastructure cost bit, but the energy's free, right? There's no input cost, right? It comes from the sun. So in the end, like, trying to build a revenue model around community batteries does seem weird to me, when it's really a service that enables a community to operate better. So I'd love to see more of it, but we've got to kind of look at it that way and say, how do we break down all the barriers that stop it being successful, rather than purely taking the economic view of, oh, it's a small version of a power station and I can trade it in the NEM to try and make money.
How can the AER fix that, Ben?
Oh, yeah, I'm going to leave that hard question to Lachlan. Where I was sort of going, I guess, and, you know, you'll forgive me because I spent 8 years in a consumer organisation and I'm never going to change. But, you know, I see a lot of sloganeering around, you know, I guess early adopter neighbourhoods or communities getting with the, you know, decarbonisation journey. And I actually have lived in this area, which is north of Wollongong, called Thurrool, which our very esteemed colleague Saul Griffiths lives in, and they've all got the T-shirts with 2515, you know, we're all sort of, you know, for a clean world, which is great. And I look outside my window where I live in 2050, and the houses are all, you know, worker cottage terraces, and, you know, there's a lot of ridges in Annandale. So the chances that solar on roofs on any of those houses, even if they could put them there, wouldn't really work. And if I look for solar panels, I can't see any. But so where I'm heading with this is what actually is evolving in our neighbourhood in 2050, and we are more diverse. You know, there's a lot of rich people and there's a lot of very, you know, low income working people and everybody in between, and there's, you know, mixed race, you know, sort of community as well. But we now have solar on we have a lot of inner city neighbourhood schools, and they've got solar on their roofs, and they can actually generate surplus energy for the neighbourhood. So I live in a huge apartment complex. We can't put solar on our roofs. But we can find places as well where we could have, you know, shared batteries, front of the meter batteries, neighbourhood batteries, whatever you want to call them, or we could even create space where we are on the grounds of the Old Children's Hospital to host batteries. So again, you start getting this much more local balancing, local sharing, which is sort of what the grid, you know, started as, really. So to me, that's where the sort of front of the meter battery discussion is sort of, is missing a trick, in the sense that it just becomes a smaller version of a firming co-located, you know, power system. It's about how do we redistribute energy around a neighbourhood, as well as, you know, time shifting.
I always think it's really interesting when we talk about these models actually to look back historically as well, because every model that we're talking about today has actually been tried before. So the first electric vehicles actually came into being around the 1900s, and there were companies that did battery swap outs for EVs in the 1900s in the US and things like that. So every model has been done before. And so community energy actually, rather than being an innovation, is actually where we started.
Yeah,
so
power.
Exactly. So the first electric supply was I think it was in Young and then in Tamworth for the electric lighting in sort of 1880s. And it was much simpler back then because we didn't actually have everything deregulated. So the challenge for community batteries, I think Simon makes this point really, really well, is bolting the battery to the ground is the simplest thing in the world. But then there's 16 different stakeholders who all need to justify the economics of it, which you can't do. So I'm going to continue my trying to be controversial. It's a genuine question as to whether or not we should just simply renationalise electricity infrastructure, because governments are going to pay for it anyway. There's not a single battery that's been installed in the grid that's operating fully merchant at the moment. So the economic, like making a battery economic, is currently being done through a government subsidy. No large-scale coal-fired power plant was ever built fully merchant. They were all built by governments. The overwhelming majority of renewables have had some form of government involvement, whether it's through grants or subsidies, or whether it's through guarantees through PPAs, which ultimately reduce the risk. So, to me, deregulation has probably failed largely definitely in the Australian market. So, if you think about the batteries and community solar as a social good, it actually probably is time to think about how we actually think about getting the asset in for the benefit of the community, and focusing less on how we make sure that all 16 stakeholders can make a profit in the process of doing that.
It's a real challenge. We're nearly out of time now. I'm going to get Wayne to give us a little wrap up and talk about where the Australia 4 project is going. I'd like to thank all our attendees here and online. any questions we haven't had answered, we'll come back and address online by email or something. And I'd like to, everyone to appreciate our panellists today.
Thanks, everybody, and I really appreciate the audience coming in here and everybody online. I'm sorry we had a little technical problems on the questions, and then I've got one thing that I felt might be very useful for everybody is this living lab that where is that at, and how how widespread will it be used?
Well, we're just in that process of interviewing people as to what would they use it for, or how would they do, what would they want from a living lab. It's an initiative of Energy System Catapult in the UK, CSIRO, a number of universities, Energy Consumers Australia, AER. So we're sort of building, what does it look like? Would it be distributed? Is it a single thing? But the idea of actually getting more homes and, more people participating to sort of trial things, because we're sort of in the area of death by trial. So this is really how do you incorporate design, what people actually do in their homes into the design of the future system. So hopefully we'll have something that we can share and socialise certainly before the end of the year. So follow my LinkedIn post and I'll make sure Tim actually boosts it everywhere.
Well, thank you very much to the panel. Thanks very much for everybody listening in, and I'm sure there's a million questions that we all like to ask, but where we go from here is that we've got one remaining online session on future technologies, which is coming up on the 28th of this month. And then on the 30th of October, we're having this session in Sydney, which will be in person, not online, because hybrid events make it very difficult. So we're going to do it in person in Sydney, and the form of this discussion will be, we'll create a communique based on the 7 presentations that we've heard, and what are the key issues coming out of that. Because this question of this transformation of the grid is incredibly complex. And there's nobody in charge at this point, but we have to have, to Lachlan's point, we need a plan. And creating this plan is incredibly difficult. For our part at Pearcey, we're linking up with people like the Australian Computer Society, Engineers Australia, and Energy Institutes to try and frame from a data and a digital point of view, what are the key challenges that we've got. Once we've understood that, then we've got a chance of a plan to actually execute something to make this transformation work. I mean, there's lots of people out there who've got the solutions, but we have to define what the problem is that we're solving, and in some sort of sequence. So when we come out the other end, we've actually got a system and a network that's fit for purpose. So this is incredibly challenging getting that together, but people want to write in with suggestions. We're going to have this sort of come to Jesus section in the 30th of October to try and summarize in this communique, then debate what these issues are, and then try and figure out a way to plan. And one of the elements of that plan will be a series of discussions in 2024 to continue this process. So without further ado, thank you very much for listening in. Thanks very much for attending, and thanks very much to the panel today. Thank you.